So today's scenario that's slightly different here is the one where it's like a Zelda game and we have this little door. And this is one scene, like this is scene 1 and this is scene 2. So like fully different scenes in your game. And if we have some items in this one or enemies or whatever it is, potions, tokens, and we have some in this one, and we collect this one and then we go and load this separate scene, and we collect these two and then we go back to this first scene, we want that to still be collected. Does that make sense to people? Okay. So the orange code is going to be to make that happen. And it uses a lot of the same concepts, so we're keeping the black code on here. So the first thing is that we need to talk a little bit about a list or an array. So just basically from the word list, like anyone want to take a stab at what they think a list is in the programming language? Do you think a list is like one item or like multiple items? Multiple items.
Maybe a list of outcomes.
A list of what?
Outcomes.
Outcomes? No, but it's on the right track. Help us out here.
Or like a list of numbers, or with specific like spots for each number?
Yeah, so a list of numbers is an important thing. So one of the properties of either a list or an array is that all of the things in the list are of the same type. So it's either like all integers, or it's all strings, or in today's use it's going to be all game objects.
It's normally like a list of the same thing that have a single variable, or like it has a variable that, like when you call the array, you call it with the number in the array.
Oh, like the index of
Yeah.
like which item in the list you're talking about. So that's with an array instead of a list.
I was gonna say everything in the list has a defined location in the list.
Yeah, so we know like the third item is always the third item, the seventh item is always the seventh item. And another thing about them, like with arrays, the size of the array is static. So whatever size you created it as, so if you created an array of like 10 items, that array is always going to have 10 slots. It'll never have 9 slots, it'll never have 11 slots. And so, something that makes a list special from an array is that it can dynamically change in size. So you can have a list that has 3 slots, and then that same list, you can add something to it, and now it has 4 slots. Does that make sense to everyone? You can also remove things, and then it has like 2 slots. And the way it actually does that, sort of behind the scenes that we don't get to see, anyone have an idea of how it might implement that? It's actually just a fancy array system.
I mean, I know that when you like want to change the size of an array, what you do is you create a new one bigger or smaller, and then you copy it and change the old one. Is that what it's doing?
That's what it's doing.
That just seems like the only efficient way to use it. Yeah. I just like because that's just how you can just implement that with an array.
Right, so it's doing it sort of like handling it for you without you needing to do it. Like it just automatically does it in the background. So it creates a new array, copies everything over that's of a new size, and then deletes the old array and gets rid of it. And like you said, it is very inefficient, right? Particularly if you have very, very large arrays. So if you have like thousands or tens of thousands of items in your array, which you very well could in large programs, then you're copying. If you want to switch it from 1,000 to 1,001, you have to copy all of those over and then delete the old one. And if you imagine that if you're doing that like every frame or something, that's going to get really heavy and bog down the processor. So if you have a lot of items, it's probably more efficient to use arrays, particularly if you aren't ever going to change the size of them. But if you only have a few items and you're lazy and it doesn't really matter because it's only a couple items and you're not dealing with it very often, then lists are just simpler. They have some other differences, but that's one of the main ones, because the lists can dynamically change in size. And so for our case, where we only have a couple of items per level, and we're not accessing this like every single frame, we're just doing it a couple times, it's not overly expensive to use a list, so that's what we're gonna do. So, to create a list, we're going to say, we can make it public or not, so I'm just gonna make it public. We might actually use its publicness later, or we will. It needs to, the item script is gonna need it, so it has to be public. And then we're gonna say like what kind of thing it holds, so if it's gonna hold integers or strings or game objects. And for this lesson, just GO equals game object. But I'm gonna get sick of typing out game object now, I'm enough room to do it. So anytime I type out GO, I mean game object. So public list, it's a capital L list, and it has these less than and greater than signs. And in here, we're gonna type GO, but we could also type int or string or transform or whatever it is, where we're gonna do a list of game objects. And so this is kind of the same as this, public. Int is the same as list GO. And then the next thing is gonna be the name of our list. So I'm gonna call this items collected. And I'm gonna set this, so normally I'd say equals and I'd write out a bunch of stuff, but my arms are not long enough to do that. So I'm gonna do equals down here. And so we use the new keyword and then list game objects like that. So there's the syntax. You'll notice that this is exactly the same as this. And we've probably seen, like if we do get component or something, where we do equals get component, and then like whatever our component. Like we've seen this whole part, we've seen this before. Here it is over here. Same syntax. Okay, so public list, a list of game objects called items collected is gonna be equal to a new list. We're just creating a new array, a new list. The array version would look very, very similar to this. Okay, and so then in our situation, we collect an item. So when that happens, this piece of code ran. So what do you think I'm gonna put here to add something to my list? Anyone wanna take a guess?
Right, you would say that the list with the index is equal to the array.
That would be how we do it in an array.
List.add.
List.add. So we're gonna do items collected dot add, and add is capitalized. And this is gonna take in this has to be the same type as the list. So this is just gonna be, how do we reference the game object of the thing that we just collided to?
Other?
Yeah, so other dot game object. Okay, and so that adds this game object, that is the thing we collided with, into the list of items collected. Okay, and it destroys it and everything else. So now we're at this, we went from this state to this state. And our list now has an item in it. So now we leave the room and we come back into the room and now we're rebuilding this scene and we get to this item here and we want to decide if we want to build this item or not. So here's the code for this item. So, what do I need to check to see over here in English?
If the list contains that item.
If the list contains the item. So, if so to the list, we're just going to do if items collect or player.items collected. And then dot contains. And then we need a reference to this game object, so we can just say game object. And so if it does contain that game object, what do we want to do? Not display it, correct. So one way we can do that is we can say like game object dot set active false. And then we want to do this. And so we would not do this here, and instead we would put it, oh, I'm getting ahead of myself. That's the end of what we do here, and then the else we do want to create it, so then we would take this and put it down here for our else. Does that make sense to people? So we're not going to instantiate this in on this line, we're gonna instantiate it in and add it to our items needed down on this line. Or whatever else that we're gonna do with it. Does that make sense? Are we good? Okay. So the problem right now, and we're getting close to being done with today's lesson. So again, we have scene 1 and we have scene 2, and our player moves from here to here. And what happens at that moment in time to our list when the player moves from scene 1 to scene 2? We had a whole bunch of things in our list of all the things we collected, and then our player goes over there, and what happens at that moment in time?
Reset.
It all reset. Everything will go back to its default state. So then we will come back to scene 1 after visiting scene 2, and it all resets again, and all of this information that we collected is all lost, it's gone. And so what we're gonna do on lesson 3 of 3 on next class is we're going to figure out how to make the player survive this scene transition and not get destroyed, but get carried over and brought over to the next scene. And then all of the data that goes with it, its health, its coins, its everything else, and how many items it's collected is all gonna go with it. Does that make sense? So if you try to put this together today, this will not work until we make that thing survive the transition. So that's what the next class will be about. Any questions over this? Okay, that's it for today.